Hello everyone, good morning, and today we will discuss Qiskit lecture number 1. So let's start. First of all, I'm going to install Qiskit using Python. After that, I also need to install Qiskit AER, and now I'm ready to import libraries. From Qiskit, import quantum circuit, and transpile function for compiling, and from Qiskit AER import AER simulator. Great, everything working. Now we are ready to define our first quantum circuit. Use the function quantum circuit. For example, I'm defining a quantum circuit, 2 quantum bits and 2 classical bits. I can also apply, for example, Hadamard gate on the first qubit, and I can use CX gate control qubit. The first qubit is the control one and the second one is the target. When the control qubit would be 1, it will invert the state of the second qubit. That's what the CX will do. And last of all, I'm going to measure 0, 1 qubits on the classical 0, 1 bits. Everything done. If you want to see the circuit, quantum circuit, you can print it and it will show you the whole circuit. Hadamard gate, X gate, measure both of them on the classical. At the bottom line is showing the classical bits 0 and 1, and it measured the Q0, Q1. Everything good. Now conceptually we have done. Now we will use a simulator. For example, I'm calling it SIM AER simulator, and then I'll compile the circuit using transpile function, quantum circuit, and simulator. Once you compile it, you can define the job where you run the simulator, and inside the bracket would be the compiled circuit. After the job, you can say result equals job dot result, and then at the end I can count result using get counts. Everything great. Let's see how many counts for each state. It's saying for 1 state the total counts are 521, and for 0 503. I think we can make a change here. If we define where we run the circuit, we can define the shorts. For example, if I am using 100 shorts, now exactly it is giving 00503 and 11521. Thank you very much. I think that's enough for the first lecture. See you next time.